We're looking at A and B, combining two events together with the word and. I think you have a sense of already some of what's going to be involved here, especially when the learning outcomes down here say, when do you multiply probabilities? Well, probably when it has something to do with and here. And then the other thing is to develop the multiplication law. That's another good hint that multiplication is going to be involved here. It might not be as simple as then we predict, because when we looked last time at adding probabilities, when you had events combined with the word or, you noticed that it wasn't just as simple as saying, well, 4 plus 3 is 7 here. It depended on whether there was an overlap or not. When you had two things that there was an overlap, you couldn't just add the two events A and B. You had to deal with the overlap and work with that. So it's going to be kind of a similar thing here when you look at A and B. There's two situations here for you to look at, analyze, and then we'll develop what's called, or what some people call, the multiplication law for probability, dealing with and. So this is, hopefully to keep it fairly simple here, this bin or something with three balls in it, you're going to pull one out at a time. There are two white ones, and I guess that one's gray or whatever, not white, I guess. They use the letters A and B here for first one out is white, second one's white. Before you start looking at kind of shortcuts or anything, it might make sense to make a sample space, make a table that shows all the possible outcomes here. You should understand this terminology here, without replacement or with replacement. So you're taking two, but without replacement means, what do you think that means? You don't put the first one back in, right? And then this is with replacement, you do put it back in. It's just a short way of saying that, because if you're choosing 5 in a row, take the first one, put it back, take the second one, put it back, take the third one, put it back. That's a lot of words. It's easier to say choose 5 with replacement, putting it back each time. So analyzing the two different things, if you go back to fundamental counting principle, combinatorics, you could predict, you could count how many outcomes there are before even writing anything out. How many outcomes are there in this first one if there's no replacement? How many things could you get on the first pick? You could get how many different things? You get 3 different things. And how many things could you get on the second pick if there is no replacement, if you don't put it back? 2, right? You can get 2 things on the second pick. Once you take one, if you happen to get this one, there's 2 left. If you happen to get this one, there's 2 left. Right? No matter what you pick first, there's 2. So there's 6 outcomes altogether. If you want to see them, you can make a table the way we've done before. This is the first draw. This is the second draw. I'm going to label these as, not to confuse us here, but I'm going to call this white 1, white number 2, and that one could be the black one. You could get the first white one, you could get the second white one, or you can get the black one. That's on your first choice, right? On the second choice, you might get the first white one, the second white one, or the black one. So it looks like there's 9 outcomes, but which ones of these are not possible here? Looks like there's 9 possible outcomes. You can get this one on the first pick, but if you get it on the first pick, yeah, it's not there anymore, right? So this one's impossible. You can't get the same one twice here. This one's impossible. This one's impossible. There's your 6 outcomes, right? There's 6 outcomes. The ones you're looking for here, because it says, where does it say this here? What's the chance of A and B is what we're looking at here. What's the chance that both of them are white is what that means, right? That they're both white, A and B, because this says first is white, second is white. The chance that they're both white, where are those on here? Where are the ones that are both white? Well, if you wrote them out here, this is W1, W2. This is get the second white one and the first white one. And then can't get that one. We can get this one. Which ones are we looking for here? If we're looking for both of them to be white, this is one of them. And this is one of them, right? There's the 2. if you write out the sample space, like this is all we've done up to now, we haven't had any shortcuts. We're going to look for a shortcut, which is what this is, this multiplication law. But up till now, we've just been counting outcomes like that. There's the whole sample space, so what does it look like the probability is? 2 out of 6, right? Again, you're looking at favorable over total if you're just counting outcomes. There's 6 outcomes altogether, and 2 of them are both of them being white.